Hi everybody. In my last video, I talked about how if both sides of an equation are exactly the same, then the equation has an infinite number of solutions. And I hope that's clear from the previous video why we get an infinite number of solutions when that happens. But I also mentioned at the end of the video that if you start out with an equation where both sides don't look exactly alike, and then in the process of solving the equation, you get to a point where both sides do look exactly alike, then the original equation that you started with has an infinite number of solutions. And that's what I want to talk about in this video. So over here, I have an equation 36x plus 8 over 4 is equal to 9x plus 2. And you can see that both sides here do not look exactly the same. So what would I start doing in solving this equation? Well, I can see that this is all being divided by 4. So one thing I might try to do is multiply both sides by 4. And of course, if I'm multiplying or dividing, I have to do it to every single term. So it's not just this or this. I would have to multiply this whole thing also by 4. So over here on the left side, these would cancel, which is to say 36x plus 8 divided by 4 and then times 4 just gives me 36x plus 8 back. And then on the other side, I have 4 times 9x would be 36x. And 4 times 2 would be 8, so I get plus 8 over here. So I can see that I have 36x plus 8 on the left side and also 36x plus 8 on the right side. Now it should be pretty clear that if both of these sides are exactly the same, then this equation must have an infinite number of solutions. No matter what number I plug in for x here and here, the result will be that this side turns out to be the same as this side because they started out exactly the same to begin with. So that should be pretty clear. But why is it that if this has an infinite number of solutions, then the original equation also has an infinite number of solutions? Now, to answer that question, what I'm going to do is I'm going to, again, just like I did a couple of videos ago, I'm going to think of the process of solving an equation as coming up with if-then statements. Except this time, instead of starting out with this equation as my antecedent and this equation as my consequent, if you remember the vocabulary from a couple of videos ago, I'm going to start with this equation as my antecedent. And I'm going to perform operations on both sides starting with this equation over here. So if I start with 36x plus 8 equals 36x plus 8, and then divide both sides by 4, which is the reverse of what I did over here, I multiplied by 4, then what would I get? I could write it in a couple of different ways. If I divide this by 4, I can just write that as 36x plus 8 over 4. Or I could write it as I could actually divide both terms and say that this is 9x plus 2. I divided both of these terms by 4. And now I can think of this as an if-then statement. If this is true, then this must also be true. But this is always true. So that means that this must also always be true. Again, this is always true because both sides are exactly the same. So if this is always true, then this, our original equation, must also always be true. So I hope now that makes a little bit more sense why, if in solving an equation, if you get to a point where both sides are equal, where both sides are exactly the same, then that means the original equation must also always be true, or in other words, must also have an infinite number of solutions. Now, there's actually another way that we can understand that we can see why the original equation also has an infinite number of solutions, and that's by using hindsight a little bit. So let's go back to this equation, which we just did in this video. And this is the equation from the last video that also turned out to have an infinite number of solutions. I'll start with this one. If I just, okay, so if I just simplify this side, then I can see that this side is really just another way of writing this side. So 2x plus 28, that's being divided by 14. So if I just simplify that, 2 divided by 14 is 1/7. So 2x over 14 is x over 7. And 28 divided by 14 is 2. So I get plus 2 over here, and then just copying the minus 2 that I had to begin with, and then just copying the rest of the equation. Then I have plus 2 minus 2, which is 0. Okay, so x over 7 plus 2 minus 2 is like x over 7 plus 0, which is just x over 7. So I get here x over 7 is equal to x over 7. So it turns out that all along, I really had x over 7 on the left side, just like I had x over 7 on the right side. It was just written in this crazy way, so I didn't even realize that it was x over 7 the whole time. Same thing over here. If I divide both of these terms in the numerator by 4, then I notice that I have 36x over 4 is 9x, and 8 over 4 is 2, so I get plus 2 over here. And that's exactly the same as what I had on the right side. So it turned out all along that my left side really was just equal to my right side, to the right side. It was just written in this crazy way that maybe the first time I looked at it, I didn't realize it. So that's using a little bit of hindsight. We didn't know to begin with that this was just a crazy version of this. And you might have equations, most of the equations that you will have turn out not to be like that. Okay, one side really is different from the other side. But if we already went through the process of solving the equation and we got to a point where both sides are exactly the same, then in hindsight, we realize that one side was really the same as the other side all along. Have a great night.